Hi everyone, so in today's video we're going to be talking about density equation manipulations. Now, a lot of the time when we're looking for density, we're not actually looking for density itself, but we might be looking for mass and volume. So one of the tricks that you can do if you have a hard time rearranging the equation is to do something called an equation triangle. So we're going to be looking at how to do one for density, and then we're going to be looking at some practice of how to use it. So the first thing that we need to do is we need to make our triangle. Now we know that our equation for density is mass divided by volume, where the mass is your mass of your object, your V is the volume of your object, and density is calculated by dividing these two. So the first thing that we're going to do is we're going to draw a triangle. Now, because we have this division right here, we need to show that in our triangle by splitting up our triangle into two parts. Then, because we have three variables, density, mass, and volume, we need to have three spots in our triangle for that. So what we're going to do is we're going to be drawing another bar at the bottom to separate the two. Now that we have our basic structure for our triangle, we're now just plugging in our variables. Now we see that density is mass divided by volume, so that means mass goes in the top square. Now since volume is underneath mass, volume goes into the first bottom square. And since we have three variables, our last variable, density, goes in our last square. Now, you're kind of wondering, how is this applicable? Well, when we're looking at an equation triangle, what we need to remember is that whenever I have variables one on top of each other, that means I am dividing them. Whenever I have variables side by side from each other, that means I am multiplying them. And one thing that I need to remember is that I need to, whenever I'm looking for something, I need to, in my triangle, I need to basically just shade it in. So let's say I'm looking for density. So I have my density triangle. I'm looking for density. Well, in my density triangle, I block out the D. So I shade it in. And what do I have left over? M and V. And how are they set up? They're set up one on top of each other. So that means density is going to be mass divided by volume. Now let's say I'm looking for mass. So then what I do in my triangle, I scratch out the M, or I cover it. And what do I have left over? I have D and V. So mass is equal to density times volume. Now let's say I'm looking for volume. Well, I do the exact same thing. I scratch out the V, and what do I have left? I have M and D, and I have M on top of D, so that means volume is equal to mass divided by density. And by putting your density equation in an equation triangle, it gives you the three possible variations. So what we're going to do now is we're actually going to be looking at two practice questions using the density triangle. So our first question is the following. What is the mass of a piece of granite whose density is 2.75 grams per centimeters cubed with a volume of 150 centimeters cubed? First thing I'm going to do, take out my density triangle. Now I'm going to write down what variables I have. I have density is equal to 2.75 grams per centimeters cubed. I have volume is equal to 150 centimeters cubed. So I have density, I have volume, I don't have mass. So I'm going to scratch out my mass. And what do I have left over? D next to V. So that means mass is going to be equal to density times volume. So now I write in my numbers 2.75 grams per centimeters cubed times 150 centimeters cubed. And when I do this mathematical equation, so I do 2.75 times 150, I get mass equal to 412.5 grams. Okay, so now we're going to do one more practice question. And in this practice question, we're going to be looking for volume. The tibia bone has a mass of 13 grams. Given that the density of the bone is 2.2 grams per centimeters cubed, what is the volume of the bone? So, first step, write my density triangle. Second step, write down my variables. So I have mass is equal to 13 grams. I have density is equal to 2.2 grams per centimeter cubed. I'm looking for volume, so I scratch out volume. And what's left is mass divided by density. So volume is equal to mass divided by density. Now I'm going to write in my variables. Volume is equal to 13 grams divided by 2.2 grams per centimeters cubed. Now I'm going to do 13 divided by 2.2, and I get my volume is equal to 5.91 centimeters cubed. So this actually saves you a lot of time and a lot of hassle from figuring out how to rearrange your equation. So what we have right here is we have three examples, and what I'd like you to do is I'd like you to go through each one, and then we're going to solve them together. So the only thing that I notice is that the density of mercury is actually chopped off. So the density of mercury, I'm just going to write it down here, density is equal to 13.55 grams per milliliter. All right, so pause the video, and then after you solve them, we're going to go through each of the answers. Okay, so you've unpaused the video, and these are our numerical answers that we have for each. I hope this helps, and if you have any other questions, just let me know. Have a great day.